In today's rapidly advancing world of automation and robotics, the ability to integrate technologies into a functional system is essential. Over the course of 3 comprehensive labs, we explored the capabilities of the Dobot Magician, a versatile robotic arm. These labs focused on fundamental concepts in robot kinematics, image processing, and robot-to-robot interaction. In this presentation, we will summarize the key learning objectives and activities from each lab, and then dive into how these skills were integrated into the final project, where teamwork and the application of these techniques allowed us to autonomously solve 2 wooden word puzzles.
In Lab 1, we focused on understanding basic robot kinematics. This included learning the fundamentals of movement, changing end effectors like the gripper and suction cup, and exploring the conveyor belt and rail systems. We also worked with I/O communication using an infrared switch and branch logic. One of the most important lessons was learning how the robot operates in a 3D coordinate system. As operators, we didn't manually control each joint. Instead, we moved the robot in an X, Y, or Z direction, and the robot calculated how to move each joint to reach that desired location. This made positioning and movement more efficient and accurate during our tests. One interesting finding was how we could create an infinite loop using the robot and a conveyor belt. By continuously placing blocks on the conveyor belt and having the robot pick them up at the front, we created a cycle that kept the robot working without interruption and without us needing to interfere. In Lab 2, we explored image acquisition and processing techniques. This included feature matching, point-to-point measurements, and calibration. We also delved into vision-guided robotics using color extraction, image morphing, and blob detection to identify objects in the robot's workspace depending on color or depending on the shape. We also explored color extraction using the blob command, which helped us isolate specific colors like red from the image. This allowed us to pick up objects such as red blocks from the workspace.
In Lab 3, we focused on robot-robot interaction and enhancing our vision-guided pick-and-place operations. Our goal was to accurately place puzzle pieces into matching slots. Our first challenge was identifying the correct letters to use. The image processing technique from Lab 2, we used the blob module to extract the specific colors and recognize the letters in our workspace. The fast match command allowed us to pinpoint the positions and the desired pieces and their orientations. Once the letters were identified, we used the robot kinematics from Lab 1 to program movements for the robotic arm. The jump command helped us avoid collisions, while the suction cup, along with the tape for better grip, ensured the letters were picked up. After picking up the letters, we moved them to the workspace of the other team's robot. When we dropped the letters off in a row, allowing for the other team to pick them up one by one. Next, our team had to prove we could solve the puzzle as well. Here we applied skills from Lab 3, using the robot-to-robot communication to start the process of solving the puzzle. Once we received the signal that the letters had been placed, we were off to the races. Placing the letters required aligning their rotations correctly. Using the fast match and the shell module techniques from Lab 3, we calculated the rotation angles of each piece and adjusted the robot's movements to match the puzzle slots. One specific challenge was handling the letters with difficult shapes like O and P. We talked about this in Lab 3. To get around this, we used clear plastic tape so that our camera would still be able to identify the different letters, but the suction cup would have added power and reliability by having a larger area to apply the suction. This allowed us to pick up and place every letter 100% of the time without fail. For our final project, we were tasked with 2 objectives. One being picking up the desired letters from our workspace and accurately placing them into the other team's workspace. The other task was receiving the letters from the other team and accurately placing them into a puzzle. This meant our bot had to sort and pass letters as well as solve a puzzle, requiring us to apply skills from all 3 labs. Throughout the project, we combined everything we had learned from understanding and programming robot movements in Lab 1 to implementing image processing for object recognition in Lab 2, and finally to mastering robot-to-robot interaction and advanced rotational alignment in Lab 3. These skills allowed us to autonomously solve the puzzle, showcasing the full potential of the Dobot robots. This project highlighted the importance of integrating multiple robotic skills to solve complex tasks. As a team, we not only completed both sorting and assembling tasks, but demonstrated the power of advanced automation techniques in robotics.